Welcome to another Teachertopian video. We're going to be covering Edexcel's GCSE in Computer Science, topic 2, and we're going to look at 2's complement, which will cover the specifications 2.1, 0.2 and 3. So if you watched the first video on topic 2, we talked about what binary numbers are and representing data in bits. Rather than denary numbers, which is base 10. We only were working with positive integers in that particular overview. But of course we have negative numbers to deal with, and that's where 2's complement comes in. And essentially what you've got to do is remember that 2's complement is about a concept called signed integers. So there are signed integers and unsigned. If it's unsigned, it can only be positive. However, signed integers can either be positive or negative. All right. And this does tend to confuse students quite a lot, this particular topic, but it's not too bad once you sort of get your head around it. So let's look at some of these concepts. I'll start by writing out the values of each of our base 2 bits in an 8-bit 1-byte system. Remember, we have 2 to the power of 0 over here. We can have a total of 2 to the power of 8 patterns, so 256 patterns. So it's 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is 255, plus the zeros includes in total 256 permutations of numbers we can have in an 8-bit system. But that doesn't include negative numbers. So 2's complement sacrifices the most significant bit column and creates a negative value here instead of a positive one. So all the ones to we're just talking about 2's complement in an 8-bit system. You can do it with other bits as well. It's always going to be the leftmost column that's going to be reserved for a negative value. And the exam questions will be quite specific with the language. They'll talk about 2's complement, or they'll talk about signed or unsigned integers. So we've got now a different range of numbers that we can have. What 64 plus 32 plus 16, 8, 4, 2 and 1. The biggest positive number we can have is 127. That would be the largest possible value we could have. So that would be nothing in this negative column, 1, 1, 1, 1, 1, 1, 1. So if we had all those numbers, we could have 127, positive number. We could also have nothing. If we put 0, 0, just put 0 in everything, we've got 0. Okay, that is 0. But the clever thing here is that we can actually have got negative numbers, and we can do up to a minus 128. So if I put a 1 here, and then all of these positive numbers are 0, well, I've got minus 128. So I can have between minus 128 and positive 127 amount of values in a 2's complement system representation in 8 bits. So the key thing here is that left MSB, most significant bit column, is a negative number instead. So hopefully that concept is relatively straightforward to you now. If we're talking about signed integers, we're talking about things that can have a negative value. And to represent that, one of the ways the computers do that is using 2's complement. Okay, and in Edexcel, you don't have to worry about decimal places or anything like that. But you might get asked about 2's complement. It's quite likely. So let's do a real world kind of example. Let's convert, I'll just make up a number. and put my colour to change, minus 57. Okay, how could we represent minus 57? And now I'm going to give you the trick, the clue to answering questions in the exam and also doing any number. Step 1 is to write out positive value in binary. So what we're going to do is we're going to represent plus 57 in binary. So let's use our columns because we've already made these. And let's pretend this would have been plus 128 for a second. So that 0, nothing, 64 doesn't go into 57, 32 does. So I'm going to have a 1 here. And 32, so we've got 25 left. 16 goes into 25, so we've got 9 left, so we need an 8 and a 1. So that's how you would write out 57 in terms of positive binary numbers. Step 2 is to flip the bits. Flip the bits. So zeros become ones and ones become zeros. So let's flip the bits. I'm just going to do it down here if you don't mind. So that 0 becomes a 1, that 0 becomes a 1, that 1 becomes a 0, that 1 becomes a 0, that 1 becomes a 0. Then we've got 1, 1 and a 0. Okay? And then step 3 is to add 1. Now I know we haven't done the video on binary addition yet. That's going to be next. But for this particular example, it's going to be relatively straightforward. So if you get confused about adding binary numbers together, you can watch the next video, which will be on binary addition. But we need to add 1 to this. So we need to add 1 over to that side here. So we're going to have eventually 1, 1, 0, 0, 0, 1, 1, and then 1. And because this is a signed integer, we know that that's minus 128. Okay, that's minus 128. This should equal minus 57. It should equal minus 57 if we've done this correctly. So we're going to, and this is the trick that I'm going to show you how to prove it. If you couldn't remember those 3 steps, let's say you get to the exam, you can't remember step 1, 2, and 3. To write out the positive value of the number that in question, to flip the bits, and then to add 1. If you couldn't remember that, then what you did remember is that the last column on the left, the most significant bit is a negative number. You did remember that. Well, you've got minus 128 plus 64. Okay, so that would be in total now minus 64, because we started off with a minus 128 and we added 64 to it, so we've got minus 64. We had nothing for 32, nothing for 16, nothing for 8, but we've got now 4, so we can add 4 to it, add 2 and add a 1. So minus 64 plus 4 is minus 60, and then minus 60 add 2 is 58, and of course with the 1 it's minus 57. Hence, we've just proved that this number is minus 57 using the 2's complement system, because we started off with that negative value because it was a 1 there. Now it should be noted that you could also have positive numbers in this system as well, just like we did here. We've got, this 0, there's nothing turned on for that column, so we don't have that minus number to begin with, so we just have positive numbers. So, but we can only represent up to 127 in 2's complement, because that left-hand side column is reserved for the negative number. Okay, So that is enough to cover pretty much any exam question. There are some exam questions that ask you to write down the steps, and in that case they would want you to remember that you flip the bits, which is actually what we call the ones complement, and then the twos complement bit is adding the one. Okay, so that would give you the 2 marks for that, and then they might give you a number to represent. You might what we'll do in the next video when we talk about binary additions, we'll have a look at addition of negative numbers as well, so that if you see an exam question it doesn't completely trip you up. Why don't we do, just before we close this video, let's just do one more. Let's do let's go the other way. So let's say we've got a signed, it will say signed integer. We've got this signed integer here. Okay, what is that? We know it's signed. So convert that to denary. Convert to denary, and you should know that denary is just base 10, how we normally count with our 10 values. So how are we going to do that? Well, it's very simple because we've just gone over it. Look at that column and know that that's minus 128. So minus 128 plus 2 plus 1. So it would have been minus 126 and then minus 125. And that would be it. So that number in binary is the equivalent of minus 125. Good. Hopefully that helped you. Please add comments or contact if you found it useful. What we'll do is we'll cover a little bit more in the binary addition video,